Welcome back, geometry students. Here we are, another video lesson as we focus today on the area of triangles. We're going to look at triangles. Now, you've probably worked with area of triangles in the past in a certain element, if you will, and we're going to look at some of the different aspects that might go with triangles and how we find the area of those so that we can apply them to real situations. So the general formula for the area of a triangle is either area equals 1/2 the base times the height, or the base times the height divided by 2. Both of these mean the same thing. They're both acceptable as long as you know what the base and the height are. And that's the trick, is usually identifying what the base and the height are as we get more advanced into geometry. Now this typically comes from rectangles, and if I cut a rectangle in half, I have half of that rectangle, and so base times height is usually for a rectangle. But anyway, these are the formulas for the area of a triangle. Now, this diagram over here, I would strongly suggest you make a copy of so that you can write down all of the different formulas. We've got triangles over here on the left. We've got a couple different types: isosceles, scalene, equilateral. And then we've got our other quadrilaterals that we'll get into: kite, parallelogram, trapezoids, rhombus, rectangle, and square. You should already know. So I would pause the video here and make sure you make a copy of this big enough in your notes, maybe a whole page, so that you can get all formulas down. Today, we are only focusing on the triangles up here. These three different types of triangles: isosceles, scalene, and equilateral. The formula is the same for all of them. Okay, and that's what you need to know. The formula is the same: 1/2 base times height, or base times height divided by 2. But we need to be careful of something, and this is the important note up here. The base and the height have to be perpendicular to each other. They have to be perpendicular, meaning they have to create a right angle somewhere. So in an isosceles triangle, typically it's this bottom angle down here, right? This side will be equal to that side, if you will. And so the right angle, base and height. In a scalene triangle, it typically happens on the outside. We would draw an imaginary line out here to show that we would drop this height. The height has a name. We call it the altitude of the triangle. The altitude. That shows us where the height should be. And sometimes we even might have to draw it on the inside of the triangle to show that that is where the perpendicular meets the base. Okay, because the sides aren't perpendicular. But the key concept is this up here when they give you pictures and what you're looking for. The base and the height of a triangle have to meet at a perpendicular. They have to meet at that 90-degree angle. So we're going to look at some examples here and see if we can't find the area of some triangles. Number one. Got a lot of different information in there. I got a 0.3 in the bottom, a 0.6 in the middle, and a 0.8 on the side. Formula is 1/2 times base times height. Remember, what we just talked about was that the base and the height must meet at a right angle. So in this case, there's my height and there's my base, because that's where they meet at a right angle, or 1/2 times the base, which is 1.3, times the height of the triangle, which is 0.6. And with some of these that are decimals, you're probably definitely going to have to use your calculator. Nothing wrong with that at all. So 1/2 times 1.3 times 0.6, and we get 0.39. 0.39, some sort of units squared. Whatever units. Same formula, 1/2 times base times height, but we got to find the base and the height for number 2. The base could be 4. It could also be 7.5. Either one is okay, because together they created a right angle. In multiplication, I can switch the order around anyway. The height of the triangle would be 7.5. If you switched around 4 and 7.5, not a big deal. So when you multiply those three out, you are going to get 15. Or 15 units squared, whatever it might be. And in the last one, notice again, we've got three different measurements. I've got from this point to this point on the triangle is 83. That slant is 34. And this out here is 28. Well, remember, we're looking for where they meet at a perpendicular. So this is my height, and this is my base. 1/2 times 83 times the 28. If I multiply those three together, 1,162 square units. So hopefully you can see in those examples very quickly why we have to identify the base and the height so that we're not using some of the other information that they give us. Well, now how do I work backwards in some of this? Okay, the area of a right triangle is 36 square inches. If the length of one leg is 6, what is the length of the other leg? Well, it's a right triangle, which is really important to us, right? Here's my right triangle. Connect the other two ends, and we'll say, here's that right angle symbol. In a right triangle, that side over here that's opposite is always called the hypotenuse. So they don't give us that, and we truly don't need it for area. One leg is 6. What's the other leg? If the area is 36. So we're going to fill in this formula. 36 for the area equals 1/2 times the base, which we'll just say is 6 in this case, times the other leg, which is x. Let's perform the operations over here. 1/2 times 6 is 3, so I've got 3x equals 36. And how do we solve that? We divide by 3. Therefore, x would equal 12. So it would have another leg that is 12 inches. So you are going to have to work backwards in some of the problems using division typically after you've multiplied on the right. Well, now what happens if they give them to you, though, as coordinates on a plane? A triangle has these three vertices. So first step, draw the triangle on the grid. -5 up here at 7. So -5, 7. And then we've got 4, 7. And then I've got 1, 2. So there is that one. Here's that side. And here is that side. Unfortunately, they don't tell us that this makes a right triangle, so we can't assume that it does. We do know the length of this side of the triangle from 5 all the way over here to, from -5 all the way over to 4. This has a unit of 9. We also know the interior height, and I can drop that straight down and create that right angle on the inside, and that height would give me from 2 all the way to 7 a height of 5. And now we know the base and the height, meaning the area is equal to 1/2 times 9 times 5, or half of 45, which is 22.5 square units. So you might have to just draw that out on a diagram onto like a coordinate plane, figure out where you would drop the straight perpendicular, right? I've got a straight y equals line, a straight x equals line. They are perpendicular, and then I can find the base and height in order to find the area. I hope you found this video helpful. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.